Okay, so this week we're going to talk about something I wanted to show you on the Moodle. And Moodle, so there is one important thing here. So is so we click on Moodle. Okay, Moodle, you can see there is a link called course evaluation. So it goes to your course. And you can see there is a link is called MBA 5313 course evaluation. So click on the above link to complete the course evaluation for spring by April 20. So this is the link. You need to complete all the survey questions by April 20. So you can see there are a lot of questions. Okay, so you just click on your choice. Okay, click on your choice, and at the bottom, well, if you have any comments, you can write here and click on down. So you finish that course survey. Okay, that's a very important thing. I just posted. Okay, so the module. Okay, I show you the question we typically have is the okay. So the typical question you have is when you post your discussion. Okay, so you can see you have quizzes, the cases, right? The quiz discussion question. And so you need to, I will show you some of them is good, some of the good discussion, some of it is not, right? So the good discussion is forum. So you're supposed to have a, you have the file attached, that's good. You know, some of the question is just like a thank you and you didn't have anything, right? So, so this is like your manager report is very detailed. I really like how that. So it's not a good discussion, but it's I want to post something related to very specific question. Okay, very specific, and so you really to refer it to some of a specific question, and so that's what I expect. Okay, what I expect. So for example, this question is talk about R square value to be high at 89.24%. Okay, this is a very specific, right? So, but the response is negative related to cost and mileage. This is good. This is specific. So do not post a question that's just like a general greetings and there is no substantial content. Okay, substantial content. So next time I will take points from your replies. Another thing is what I talk about is in your initial post, okay, make sure so you have the post before Thursday, okay, before Thursday. So that's a good, you know, say the Thursday you post it. And so I already extend 1 day for your initial post. So make sure you post before the deadline. If you post late, okay, sometimes I would take 50% off. So it's maximum is 6%, you will get only 3. So that's because you're late, the other student cannot read your initial thread, and they couldn't make any comments. That's the 2 things very important. Okay, so today I want to introduce the most important skill we usually have is from this chapter. We talk about chapter 14 and 15. So we, okay, so I want to show you the example, okay, we have. And so a lot of students are talking about the how to do this statistics in Excel. So I will show you the question we talk about in chapter 14 and 15. And basically there's 2 chapters are talking about regression. So I want to show you the PowerPoint slides. The PowerPoint slides is right here. So we have, this is the topic for chapter 14. Chapter 14 is a simple linear regression. Okay, simple linear regression is very common, is very useful. And most of the cases, we use only a simple linear regression. So the skill you need to learn doing business statistics is called regression. So the regression, the method is called least square. Okay, sometimes we call this one ordinary least square. Okay, let me double editing that. It's called ordinary least square method. You may see a lot of research doing OLS method. OLS is ordinary least square method. Simple linear regression. Okay, what is a simple linear regression is the regression analysis, you have one dependent variable and one independent variable. So that's a simple linear regression. And okay, so you have the y, which is your dependent variable. Okay, the x is your independent variable. So using that independent variable to predict your dependent variable. So for example, you can use the price to predict the quantity of the products you sold, right? So this is a gas price and how many cars will be sold on the market. That's a good relation between these two, right? Okay, so that's we call the relationship between y and x. So use x to predict y. Okay, and so the beta 0 and beta 1, the beta 0 is we call this one is called intercept. Okay, all the parameters. The parameters this is called intercept, and then this is the one is called coefficient. So beta 0 is intercept, okay, of the regression line, and the beta 1 is the coefficient. Sometimes we're using this one for simple linear regression is the slope of the regression line. Okay, the slope. Okay, and so when you plot the relationship between these 2 variables, basically it's a linear regression. If this slope is positive, you can find a line which is an upward trend. What that means, when the x increases, the y will increase as well. Okay, if the slope is negative, the line will be downward trend. Okay, and the horizontal line is the beta is 0. Okay, beta 0 is that whatever the price changes, the products, the quantity of the products sold will be the same. Okay, it's not affected. Okay, so after you do the simple linear regression, and you will come out with a regression equation, which is going to be the y hat equal to intercept plus the coefficient times the independent variable. And you can estimate. And so basically, I wanted to see what is the least square. The least square is you minimize the y minus the y you estimate. Okay, you square based and sum of them up. So we call this one basically this is a deviation. What is the value? The value deviate from the line, and then you square them, sum them up. You minimize this number. Okay, you can solve for intercept and the slope. Okay, and so in order for you to understand this, I'm going to use this example. Okay, this is called Army Pizza Parlor Restaurant. Okay, this is the student population, and this is a quarterly sales. Okay, and quarterly sales, and this is a we have this is a X, this is a Y. Use the student population to forecast the quarterly sales. How you do that? So you can okay, you can find different restaurants. Okay, like take a sample of 10, like a 10 restaurant. Okay, the first restaurant, you know, typically has 2,000 students come to eat, and the quarterly sales is 58,000. Okay, and there another restaurant have a 6,000 student population. The quarterly sales 105,000. So you collect all the data for 10 restaurants and to put in different column. Okay, so let's do this, and so I will show you how to do the regression. And okay, this is my data. Okay, so this is the data you can see here. Because I already typed this number in here. Maybe if we want to see bigger numbers. Okay, this is the quarterly sales and student population. This is the restaurant. Okay, how you do that? The first, when you do a regression, I wanted to let you know by default, when you open Excel spreadsheet, there is no that button in the code regression. So what you have to do is you click on File, you go File, and click on Option. Okay, File Option, and there's an Add In. Click on Add In. Okay, you can see Data Analysis Pack, and then you click on Add Excel Add In, and you click on Go. Okay, and then you choose this data analysis pack, click on that, and you click on solver. So the solver is also very helpful. I just wanted to add it to it. We may not use this one this time, but we do have a solver. We wanted to add it to it. Okay, you can only add analysis to pack. Okay, click on OK. Okay, when you do that, and so where you can find your data analysis pack, okay, you click on data, and you can see you have the data analysis button right here. And also you have the solver added to it. If you didn't do that, so you will not find this two button and you cannot do analysis, regression analysis. Okay. So what we could do is that you can see this is the X, this is the Y variable, and then you select all these two columns. Okay, you select these two columns, and you can do insert a graph, which is this graph is called a scatter plot. So using the scatter, okay, you do the scatter plot. Okay, so when you select the data, and you have a scatter. Okay, the scatter plot. Okay, scatter plot, and then you can click on this chart elements, and so you can do, and you add this axis title, so the axis title, and you see this is going to be the title, and you have is called okay, this is your quarterly sales. This is quarterly sales. And then you have the Y, this is X, is student population. Okay, you have the student population. Okay, this is your X, basically. So by default, okay, the column on the left is going to be X, on the right will be Y. Y is the vertical line, vertical one. This is the X as on the horizontal line, okay. So you can see this some of the numbers. For this one, it's like this is a point, this is a 2, right? 2 students, and the quarterly sales is 58,000, so 58. So that's all the points we have, total 10 points. How you gonna do this? Okay, how do you know the relationship between these two? So we can do is that you click on there, and you can see you add a trend line, okay, trend line, and then you can see this is the trend you already have, right? You have the trend. So you have the trend line, and then you have this button right here, okay. So that's how you gonna how you get the graph, how you get the graph, and so you can see this is the data series, okay. And when you format your trend line, okay, you right click the trend line, format that trend line is linear, and also you can choose display equation on the chart. That's the equation you can get right here, and also you display the R square right on the chart. So you have the R square and this estimate equation. Okay, and this is how you do this. Everything you got this trend line. You just click on the trend line, and then you right click, format your trend line, and then we'll get these two. You will have the estimation. And that's the student typically ask me the question about how to estimate the equation. Okay, this is how you get the equation. It's 60 plus 5x. Okay, I will show you. This is how you get 5x plus 60, and then how you get the square. Okay, and okay, you can do that, and then you have okay. So this is how the graph, how you can get a graph using Excel. Okay, and okay, so next you wanted to know what is the coefficient determination. The coefficient determination is a sum of total square and sum of the square and the sum of the errors. So you have a 3 different part, and this going to be the sum of your regression, sum of your totals, sum of your total squares, and then you can get the coefficient determination. This is the R square. R square is the coefficient determination, which is what we got here. It's called R square, 0.9. So what that means, okay, the coefficient of a determination, if the R square is 0.9, that means 90%, okay, 90% of the variance of quarterly cells can be explained by the student's population. It can be explained by student population. So that means student population is a very important factor. That factor count about 90% of the variance of your quarterly cells. Okay, that's so basically we wanted to know if this model is good or not. You just look at the R square. So when the R square is higher, that means that means that you do not have much independent, missing any independent variable. So you already consider all the possible independent variable, all possible factors, right? Okay, so now we have another one we could see here. So it's you have the line, and then you have R square and F statistics. Right? You have F statistics, T statistics, and so where you can get the coefficient. Okay, so okay, I want to show you how you get this one. Because we using the graph, it doesn't show you what is that. Okay, sometimes we can using a simple regression. Is a simple function is called slope. You can do the slope function, and so you can choose a y, is the known y's. This is your x. And so you just select these two columns. Okay, you know that this is your function, the slope. Okay, y equal to 5 times x plus 60. 5 is your slope. Okay, this is the slope, right? Okay, so what we do is that we're gonna click on data analysis. Okay, data analysis, and you're looking for regression. You click on OK. Okay, input y, this is your y. And then you input x, because this is all your x. Okay, and then you wanted to keep the residues. Okay, let's say we have residues, and we need to, okay, 95% confidence. Okay, so we just click on OK. Okay, and then you come out with this summary output. Okay, you see the summary output. Okay, remember, so we have that, the R square. You have the R square, which is 0.9. And that's the same, or we have, this is the R square, 0.9. Okay, and we have the F statistics. Okay, this is your F statistics. And you have the sum of a square. Okay, sum of the square, and then you have the total square, sum of square. And then the most important thing, you can see you have okay, the coefficient. Okay, the coefficient, this is what we need to know. Okay, the coefficient is 60, intercept is 60, and the coefficient is 5. Okay, so we want it to be this one. Okay, if you don't have that chart, okay, what you can do is you can just y equal to the x variable is 5x plus 60. Okay, that's your estimate equation. The estimate equation, can you get this one from the coefficient? Okay, so you can get from the ANOVA table and to get the intercept plus the coefficient times x variable. This is your estimate equation. Okay, how do you know that this variable is significant or not? Okay, you look at the t-statistics. Okay, the t-statistics. Okay, the t-statistics is typically is significant or not significant is based on the p-value. So the p-value is 0.54, -0.05. That means there are going to be 5 zeros before 2.54. So it's very small, the p-value. So the t-statistics for the x variable, because this t-statistics is less than 0.5. So we statistical significance, we have less than 0.5, less than 0.1, or it's less than, it's not 0.5, it's 0.05. Or it's less than 0.001, okay? And so the significance level, we have 3 different levels. We usually consider that t-statistics is significant or not, okay? And so this number, the p-value is less than 0.01, okay? Okay, we can see this is a 1%, okay, 1% confidence. This is 1%, or 99% of confidence that this is significant. This is 95%, okay, and this is a 99% of the confidence that this variable is significant. So significant. So that's how you can get the estimate equation and the t-statistics, okay? So we do this for simple linear regression. And also we can do is for multiple regression. So multiple regression, and this is okay, I will show you the one we have, chapter 15. Okay, chapter 15 is that you do multiple regression model. Multiple regression is you have 2 or more factors. It's not only one factor, 2 or more factors. And so this is going to be, you see x1 and 2. Okay, so for example, you have more factors other than only one independent variable. Okay, we have this example is that you estimate the travel time using the miles traveled deliveries. Okay, the truck company, how many deliveries or how many miles they traveled to forecast the travel time. So you can see the travel time is associated with deliveries and the miles that they travel, right? They travel. Okay, so we're gonna do this, and so we using the data right here, right? The data. So you can do as using click on data, data analysis, and we choose regression. Okay, there's regression. Okay, and we select the Y. Okay, the Y, which is the travel time, and then you choose X. Okay, this one, make sure so you select the both columns. Okay, there's both columns because you have two variables, two independent variables, and then you have the residues, and then click on OK. So when you click on OK, you can see you have the output, right? Output here. Yeah, so that's your multiple linear regression. So you have two or more factors. So you can see we talk about the variables. Okay, we have, okay, they have x. Okay, this is a y2, right? And you have the estimate equation as a y equal to intercept, okay, negative 0.868 plus 0.061 x1 plus 0.923 x2. Okay, so that's your estimate equation because you wanted to look at all those the numbers you have is right here, okay, in a coefficient. You wanted to check this is a statistically significant or not. You see the numbers, okay, less than 0.05. Okay, that means this coefficient is significant. Okay, so that's some of the regression output, and to make sure how you estimate what is the estimate equation and how to interpret, right? How to interpret. So other things are similar to the linear regression. Okay. Okay. Do you have any questions? Okay. Make sure.
No, sir.
Okay. Make sure you have your name typed here. And for the students, I wanted to come here late. I just wanted to show you again. We add a new link here. Is a course evaluation due this by April 20. Okay, and when you have something, you have late assignment or you are affected by the virus, and please send me your email. So as let me know. So I will try to talk to my supervisor and to try to accommodate in this situation. Okay. If you don't have any questions, I'm going to end the meeting. Okay, next time I think is going to be late April or late April or early May, but I will post on a Moodle, so you will see our next meeting, maybe 2 weeks later. Okay, any questions is good? Okay, okay, see you next meeting.